When it comes to framework designing, most of the automation testers are designing the framework wrong way. Yes, you heard it right. Solid principles are one of the foundational framework designing principles which are generally ignored by automation testers, and mostly people are unaware of this or they are fearful of learning it. But in this video, I am going to explain solid principles in very simple words and with very simple examples. So once you watch this video, this is going to give you complete insight of solid framework and how it is being used in frameworks. So let's start. First thing first. So for those who are very new to the solid framework and even don't know and heard of this solid word before, so for them, solid principle is an application designing framework, and it is a designing principle basically which is used in application designing. So solid principles are one of the most used software application designing principles which are very foundational in any software application designing. With the help of solid principles, we make our code more usable, maintainable, and scalable in real time. Okay, so let's start solid principles. So solid principles, if you see, each of the character is acronym for SRE, which is single responsibility principle. O is an acronym for OCP, which is open closed principle. L is acronym for LSP, which is Liskov substitution principle. I is ISP, which is interface substitution principle. And D is DIP, which is dependency inversion principle. So we will be going through each one of them one by one. So don't worry if you don't know or aware of these. I'll explain each one of them one by one. So let's start with single responsibility principle. So here, if you see, I have divided this principle to understand it better in 5 different categories. First is we will understand what is definition, and we will take one scenario through which we are going to understand these principles. So, and what is the problem before we apply this each of the principles? Like in this case, we are going to see what problems we are facing before we apply single responsibility principle, and we will also see what are the solutions, like how we can implement SRP and how it is going to resolve our problem. Next is the benefits. So we will also see what benefits it is driving for us. So let's go ahead for SRP. Let's understand the definition. So the SRP definition, if you see, it says a class should only have one reason to change. That means it should only have one job or responsibility. Okay, so what does this mean basically? So if you consider one home is there, and in a single room there is kitchen also, dining table is also there, bedroom is also there. So how that room will look? It will be more of messy, right? So how about if we divide each one of the rooms in separate rooms? Like if we want kitchen, then whatever activity is related to kitchen is going to go in the kitchen room, and whatever activity is related to other rooms, we are going to separate each room out in that whole house, and that is going to give us more and more clarity, and also we will be able to understand better the whole room, right? So similarly in here also, SRP says that each class in your software development life cycle or your application should have single responsibility. So for example, we'll see this also in an example. So let's go ahead and understand one scenario. So let's suppose you have a user class, okay, that handles everything related to users. Okay, so for example, storing user details. If there you are supposed to be storing the user details, there is one method in that user class itself. We'll see this using code also, so don't worry if you are not understanding till this point also. So we are going to have validate user data, that is also stored in class user class. Saving users to the database, that is also in there. So everything related to the user functionality you have put in single class. So that's where what will be the problem, we'll see that also. So what is the problem? So the first problem which you will see, that user class becomes cluttered with too many responsibilities, right? So what are those too many responsibilities? For example, we have assigned that to send welcome email also, saving users to the database also, validating that user also, whether user has entered correct username or not, email or not. So all those responsibilities of validating user data also is getting handled by same user class. So let's understand with a code example. So let's see one code example of SRP before we are applying this single responsibility principle. So over here, if you see one user class is there, and in that user class, there is name, there is email, there is validate user data also is there. There is public Boolean validate is there. So what we are doing, we have method to validate the user data. We have method to save the user to database. We have method to send the welcome email. So what will be the problem basically over here? This says that any change to email sending logic. So if we are going to send or if we are going to change something in email sending logic, that is going to require to modify the whole user class, right? And potentially this can implement or this can lead to bug in the system. So that's why it is more of, we are doing everything in one place, and that's why it is more prone to have bugs or issues going further, because we are making too many changes and the one class is handling so many things. So if we are going to change one thing, then other thing may also get impacted. So that is the problem statement which SRP is going to handle. So what SRP says over here, it says break down the user class into multiple classes. So instead of having all these things in one single class, SRP says instead of using all these things in single class, you can break down the whole user class into multiple classes, such that each class is going to handle single responsibility. So how come that is going to handle the single responsibility? We'll understand that using one code. So over here, if you see, now we have the same code. We have changed the same code. This code was there, user, where everything was there in single class. Now we have modified this code into multiple classes. So now this user class is going to have only email, numbers, and getters and setters. Okay. Now we have another class which is user validator. So what it is going to have? It is going to have all the validation related logic. So let's suppose user has entered wrong email, wrong username, or something like that. This class is going to handle all those validation logic. And if something is which is not as per the business logic, it is going to handle all those rejections. Okay, so this user validator is now going to handle all those validations part. Another thing is, another class we have created is for saving the user. Okay, so whatever user is going to push into the repository, that saving part is going to handle by this user repository class. And here we have one save method. This method is going to have the database save logic, which is going to handle the saving part of the user. Another is email service. We have divided into single class of email service, which is going to be responsible for sending welcome email. So now if we are going to change anything in validation logic, we need not to touch the functionalities of this user repository or saving logic or sending welcome email logic. Right? So with this approach, basically what we did, we had divided the responsibility of multiple things into single thing, and that's why we are now able to maintain it better. And if something new comes up in the user class, we are going to accommodate that as well, right? So now what are the benefits of this? Basically simplified code maintenance. So if we are going to change something in validation logic, or we are going to change something in welcome email service logic, then easily we can maintain that, and we can go and just make changes in those code part, and rest of them is not going to be, we need not to worry about rest of the code, right? Reduces the risk of bugs, because we are not making changes at each and every place. It is not going to affect different areas of user class. Enhances the code readability. So now we are using each class for different actions. So easily we can understand, okay, user validator class is there. So this must be using getting used for something related to user validation part. User repository. So basically we must be using it for the saving of the users. Email service. So this is something to do with the email service. So this way it is more easier to understand, easier to maintain, and easier to reduce the risk of bug. Okay, so this seems very easy to understand, right? SRP simply means a single responsibility principle, which means if any particular class is handling too many responsibilities, then we need to simply break it down into multiple classes so that it can be easily maintainable, reduces the risk of the bugs, and also it can easily be readable. So with that, let's move on to second principle, which is OCP. So now here OCP simply means open closed principle. So we will understand that again with similar steps. So first is definition. Let's understand what it says in terms of a definition. So software entities. Here software entities means classes, modules, or any functions, etc. Okay, should be open for extension but closed for modification. So once again, I am repeating, each class or functions should be open for extension. That means it can be extended, right? If new functionality comes, it can be extended, but same class should not be modified. So that's what it says. Let's understand more on this. This means adding features to a code base without altering existing code. Okay, so like installing a new module without tearing down existing structures. So here this definition, if you see, it should be open for extension. That means we should be able to add new feature into the existing code, but existing code itself should not be modified. So that's where it means it should be closed for modification, but open for extension. Okay, so let's understand more on this with a scenario. So here we are maintaining one scenario which says user management system needs to support different types of users, right? So now we have one user class, right? And now user can be of different types. For example, user can be a regular user, or any user can also be admin type of user, right? So who has some privileges of admins, right? So we are going to take this scenario. Now let's understand what is the problem before we apply this OCP, okay, open closed principle. Now we will see this, that user class is directly modified whenever a new user type is introduced. Okay, so since we'll understand this with the code also. So just understand what I'm trying to say here. We'll explain this with the code also. So user class is directly modified whenever a new user type is introduced, risking the stability of the existing system. That means if we have one class which is handling only regular user, now another requirement came, okay, we have another type of user who is admin user, who has some extra features or extra responsibility for admin users or extra privileges, right? So we need to add that user also in the current existing class or existing function, right? So how we can achieve this? We'll see this with a class. So over here, if you see, this was the class, right? User class. Private, these are some of the fields, name, email, role, or something. Now we need to include assign role method, which is going to assign the specific role to the user, right? So now here, if you see, access control is the method which is going to give the access as per the user requirement, right? So if we have role as admin, then it is going to behave like admin, like it is going to have some specific logic as per the admin. Maybe, some part of the application is going to be accessible to admin only. And if role is equal to the regular user or user, then it should not have some specific privileges, right? So this is how we are going to modify when we don't have OCP, right? Open closed principle is not applied over here. Because of this, we have user class. Now we came up with a new requirement of assigning a new user type, which is admin user. So how are we going to do that? We had modified the existing class itself. We had modified over here user class, and because of that, we have introduced one method, assign role, and access control. So through this, we are going to control different logic as per admin and as per the regular user. So this is what we did here. Now let's come back to the solution. So how are we going to, handle this? Because we had one class which was modified because we had one new requirement. And what our OCP says, it says that adding feature to the code base without altering existing code, which means we should never have modified this class. So we should have the option to extend this class such that we can implement new feature, but we should not modify this code. Okay. Modification should only happen because it is required to modify the logic of that particular class. So whatever responsibility is related to that particular class is required, only those places we are going to change the logic. Otherwise, we are not. So now how are we going to maintain this? Like, how are we going to handle this problem? So for that, we have solution to use interfaces or inheritance, okay, to allow extending the functionality without modifying the user class. Okay, so through this, we can implement open close principle in our current code. So what it says, so this is how we can implement. There are two ways. It says either we can, or both also, you can use inheritance or interfaces, or both also, to allow extending the functionality without modifying the code. So over here, if you see, now instead of implementing in such a way that only one class is handling that request, and because we came up with new feature to add on, we had to modify the existing code, which was not required in case of OCP. So over here, if you see user, we had created one abstract class, and this abstract class is going to have name, email, and access control. So because different type of users, today admin user came up, tomorrow any other contract user may come up. So we definitely should have the extension possibility, but if modification is required, that should only happen because we wanted to change some functionality related to the admin user, not because we are going to add some more users type, and because of that we are changing the existing code. So over here, if you see, this is our abstract user class in which we have name, email, and access control. These are the methods, and since this is abstract method, so whichever class is going to extend this class, this user class, has to give the implementation of access control. So now public class admin user is extending this user class. That means it has to provide the implementation to access control. Now whatever admin related logic is there, or business rules are there, or whatever features or privileges related to admin is there, this class can definitely handle that, right? Similarly, regular user also can extend, and whatever privileges or permissions are allowed to a regular user, that is also going to be get handled in this access control. Now tomorrow, if contract user comes up and contract user related functionality also we need to add in the user class, we can simply create another class, contract user, and that is going to extend the user, and whatever is the new functionality related to access control, that definitely can be handled over there, right? So this way, what we are doing, we have closed the existing functionality for modification, but we kept open the existing structure to add more and more features. So easily here, if you see, we can add more and more features. Existing code is not going to get hampered or get changed because of we are adding new feature, right? So this way we can handle this OCP. Now, what are the benefits? More or less, you will see the similar kind of benefits in all of 5 different principles. It also reduces the bugs because we are not changing the stable code. And this is also going to have a stable, flexible system, and it can also be scalable because if tomorrow 10 different types of users comes up, we need not to change the existing functionality because we are adding the new feature, right? So because of this, we have flexible and scalable systems we are building. And because of this principle, we are not changing the existing functionality, but we are open to add new functionality. So that's related to the OCP. So till this point, it seems very easy and understandable because we understood SRP, which is single responsibility principle, and we understood OCP, which is open close principle. And more or less, if you see, the both principles are around changing the existing code. Basically, we are not, basically, if you see both, so till this point, it seems very easy to understand because SRP, single responsibility principle, or OCP, which is open close principle, both revolves around discouraging existing code changes and creating the new thing, right? And through that, we can maintain the scalable and flexible systems to scale. And till this point, people understand, and after this, they give up because they think that LID part will be more or less difficult to understand. But believe me, this is going to be easiest one to understand. And through this, you will understand what is Liskov substitution principle, because it seems very, very tough to understand, but it is not. If you give some more attention to this, what I'm trying to say over here, it will be easier for you and you need not to look upon multiple videos. So this is going to be very easy for you. So let's dive in again. So, okay, third is LSP, which is Liskov substitution principle. So what is this? We'll again try to understand with 5 different things, which is definition. We'll go through the definition. What it says, subtypes must be substitutable for their base types without altering the correctness of the program. It seems little messy, right? Okay, so now let's understand with a simple example. So over here, if you see, this is class A and class B is a child class, A is parent class, and class B is extending class A, which means A is getting extended by B and B is a child class. Over here, if you see, class A has one method, method 1, and this is one form of code where class A's object is calling method 1. Okay, so what Liskov substitution principle says, wherever parent class is being used, it should be, we need to write our code such that if we are using child class in place of parent class, then also our code should not break. So if we are creating the same reference variable for class B and we are calling method 1, then also our code should not break. This is the simplest description of this Liskov substitution principle. We'll see more. Now let's understand with a scenario. So what is the scenario over here? You are working with a user management system that includes different types of users, like we did in the previous example, right? So we have regular user, we have admin user, and these users share common functionality, like I showed you in case of A and B, right? But admin users have some additional privileges, right? Because in that case, admins have different privileges, but which other users may not, right? Okay, so let's understand with an example. Over here, if you see, you are working with a user management system that includes different types of users, like we did in the previous example, right? So we have regular user, we have admin user, and these users share some common functionality because admin users definitely will have some different privileges than other users. So in that case, admin users have some additional privileges. So we'll see how we can mimic this and apply Liskov substitution principle in this case. We'll see one example. So in this case here, if you see this example, we have user class, which has name and email fields, and there is one method disable account. So normal user can disable their account by themselves. So that's what the logic over here, and user can disable. Now, but in this case over here, if you see, we have public class admin user, which is extending user, And since our admin user is such that admin user cannot disable the account. So in this case, we need to override the disable account functionality in such a way that admin user should not be able to disable the account, right? So in this case, if somebody calls admin user and with that it calls this disable account method, then they should get the some kind of exception or error that admins are not allowed to disable their own accounts, right? So that's what is the problem over here. Because if we are going to change the user with admin user, by default, user is going to have the disable account feature, but admin user will not have. So wherever we will change this, we are going to get error that admin user now don't have the access to disable the account. So that's what is the problem in this Liskov substitution principle, because we are not able to substitute. Our user is going to have disable account, but admin is not able to. So if we swap user with this with admin user will start getting the error that it don't have access to change or disable the account. So that is the problem basically in this case. So if you want to go through again and look over what I am saying, you can go back and see again. It is going to be very, very easy to understand. Now here, if you see, I have mentioned that, for instance, admin user overrides a method in user to restrict certain actions like disabling account, which is a regular user can do, but admin should not. That's what I explained here. Okay, so now if you see over here, we have one user. So user object is here and user object is calling this disable account. Now, if we use this instead of this user, we are going to use admin user, then this user is going to call this method, admin users method, right? Which is this method. And in this place, we are going to get the error. That's what I was trying to explain over here. And this is not allowed in LSP. And that's what LSP says, that if we are doing this way, then it should not give us error, right? So if we have one object of user class and parent class basically, and one method is getting called from the parent or from the child, then it should be able to substitute the parent class. So over here, what we are doing, we are substituting the parent class with child class. So what is the child class? Admin user. So we, in this case, in this implementation over here, we are going to get the error that admin user don't have the privilege to disable account. So this is the problem statement basically which LSP solves. We'll see how it is going to solve this problem. So in this case, we have to make some arrangement such that we don't get the error while we are substituting the child class in place of parent class, right? So we'll see what way we can, we can change this. So what we can do here also, this is the solution for where this is where we are implementing LSP. So how are we implementing? We have created one user class, and in name, email, and disable account like it was. This user class have not been changed, but in here in the under admin user, which is extending user. So over here, if you see, we have public void disable account. So what we are doing, we are implementing this disable account in such a way that it is not going to break the functionality. How? If this instance of admin user, basically we are making sure that if somebody is creating admin users object, right? In this case here. So if somebody is creating the admin users object, we are making sure if this object is admin user, then we can simply put some validation or some message that admin cannot disable their account. Otherwise, what we are doing, we are calling the disable account from the parent class. That's what it is doing, right? So if admin user is there, we are going to throw some error or something like that. And if it is the normal user, then we are calling the method from the parent class itself. In both of the cases, in this case, if we are using this way, so by default, this method is getting called. If we are using this way, like we are creating the child class object, admin users object, and we are calling this disable account. In that case, it is going to make sure that if admin user is getting called, then disable account method is going to check whether the object is of admin user or it is an object of the regular user or parent class object. So if it is parent class object, it is going to call the parents method, disable account method. And if it is the same class object, like in this case admins object, then it is going to simply throw some error message saying that admin cannot disable their own account because that is the functionality of admin user in this case. So this is how basically we can implement LSP, which says that any parent class or child class should be able to substitute their parent class, right? Wherever they are going to get called, it should not break the functionality. So that's what LSP says, or Liskov substitution principle says. Once you put focus and attention to that, it is very easy to understand. Just you have to make sure you are focused and pay attention to it. It is very easy to understand, and believe me, if you once understood it, you are never going to forget it. So make sure you have full focus while understanding this. And I am reiterating this again. So LSP simply says that wherever parents class object is getting called, it should be substitutable by the child class object. So basically our code should be able to handle wherever we are substituting the child class with parent class, or parent class is getting substituted by the child class. So both ways, it should not break the existing functionality. That's what LSP says. So what is the benefits of this LSP? Here, if you see, the benefit is users can be substituted reliably without introducing unexpected behavior. So wherever it is required to substitute each of them, whether parents or child classes, you can easily substitute it, and it enhances the code predictability and consistency basically, because you are going to make sure that wherever you are changing, in case it is required to change your parent with the child class or child class with parent class, you are not going to break the existing functionality. Now next we have ISP, which is interface segregation principle. So what it says, it is very easy to understand, so don't worry about this. So I'll just clean this up here. And now if you understand the definition, so it says that clients should not be forced to depend upon interfaces they do not use. In simplest word, if you have one interface where there are multiple different types of methods are there, and one interface is getting extended by any particular class, then it has to implement all different methods which are there in the interface. So in that case, what ISP says, it says that any class should not be bound to implement all those methods in the interface which is not related to that particular class. We'll understand this with a scenario, so don't worry about that. Here, understand the scenario. So we'll go. So let's suppose we have one user class, okay? One user class which is going to implement an interface that has methods irrelevant to certain types of users. So I'll show you what is the problem over here with a code example. Okay, so for example, over here, it says that there are two types of users. In our case, the example we are taking, we have two different types of users. One is regular user and another one is admin user. So now they are going to over here, if you see, I'll just make it a little small. So over here, if you see, this is the interface, user operations interface. Okay, and this interface, what it is doing, it has different methods, right? Login, logout, reset password, generate report. So this generate report method is only required by the admins, right? But since this is part of user operations, so that's why it is kept over here also, right? And this method is going to be implemented by the admins. So what we are doing over here, if you see, admin user is going to implement user operations. So what it has to do, it has to implement all those methods mentioned in the interface over here. So it has to give logic or implementation to login, it has to give implementation to logout, it has to give implementation to reset password, it also has to give implementation to generate report. it is fine, right? Because generate report was only for admins. So till this point, everything good, everything goes good, and whatever was the required method implementations have been provided by admin. So in this case, everything is good. But in case of regular user, you see, if regular user is going to implement user operations, then it has to give the implementation to login, log out, reset password, and generate report. So it has to give the implementation to generate report. But in this case, if you see, because regular user is not entitled to generate report, and because of that, over here, if you see, regular user don't need this, but implement, but it has to implement because it is implementing one interface which is user operations, and it has one method which is not related with the normal user. So this is the problem in this case in ISP. So this is the problem we are going to resolve over here with the example. So what is the solution to this? In this case, the solution is we are again going to break the interface, which is very big, and more unrelated methods are kept over there. And if any particular user has to extend the interface, it has to implement all those methods which are not relevant to that particular user. So in this case, what we are going to do, we are going to create different interfaces. So what we did, we broke down that user operations interface into multiple interfaces. So what is this? So we are segregating the interfaces based on their use case type and whatever methods it is going to hold. So what we did, public interface, auth operations. So now this is one interface which we broke out of users operation. This auth operation, basically authentication operations, login, logout, it is going to have password operations. This particular interface is going to have reset password, public interface, report operations. So whatever report generation related to the methods are there, that is going to be here. And now if admin user has to implement, admin user is going to implement all those interfaces which are required to that particular user. So admin user is going to implement auth operations, password operations, and report operation, because it has to implement the report related methods as well, right? So in here, it is admin user is going to give implementation to all those methods, which is fine. Previously also it was fine for admin user, but in this case, regular user, now after we implemented ISP interface segregation principle, what we are doing, we have implemented only those interfaces which are required for regular users. So auth operations and password operations were the only relevant methods or interfaces which regular user is going to implement. So in this case, we have just implemented those interfaces which were required for regular user. So now regular user has not to implement those interface methods which are not related with regular user. So this is very simple to understand. ISP is very simple to understand, because one big interface, instead of having one big interface with all different methods which are not correlated with different types of users, we are going to break the big interface down in smaller interfaces and segregate them into multiple interfaces, which easily can be extended or implemented by different user class or classes which are related to those interfaces. Okay, so that is what ISP says. ISP is interface segregation principle, and it is only to break down the big interface into smaller ones so that relevant interface implementation can be provided to different classes which are only related methods are implementing. Now let's see what are the benefits of this. Benefits of this is user implement only those methods they need. We have just talked about this. It reduces the unnecessary dependencies and enhances code clarity. Okay, so this was interface segregation principle. Okay, so last principle is DIP, which is dependency inversion principle. Let's understand the definition of it. So its definition basically says high-level modules should not depend on low-level modules, okay? And both should depend on abstractions. Now, you must be thinking what it means. Okay, so let me explain you here. So any application, if you see over here in this particular diagram, any application has three different layers. Okay. First is the top layer or the UI part, which user interacts with, right? And second one is middle layer or business logic. So whenever you have middle layer, you are generally putting the business logic of any particular application. And the third and bottom layer is actual implementation of the tasks or methods. So over here, if I just explain you, let's suppose, you have one scenario where you are developing one user service. And what is that user service is doing? That user service class is going to handle user related operations, such as maybe, registering the user, saving their informations to the database. Now, to register any particular user, saving their information to the database, it requires to have one database, right? Now, in this case, let's understand, let's suppose we have one SQL database. Okay. So MySQL database is the only class which has been implemented over here. And this is the database class which is going to store all the operations. So whether to register the particular user or saving their information, all is going into the SQL database itself. Now this is the scenario. Okay. Now let's understand the problem before implementing this whole scenario. Okay. So now you see this MySQL database, this is one class, right? And user service is another class, correct? Now this user service has MySQL database equal new MySQL database, correct? Now this user service is having what? Register user and like that, save user, something like that, right? Database dot save is another method which is given under MySQL database. So what is happening over here? This whole code is very tightly coupled to MySQL database. What does this mean? Tightly coupled means what? So tightly coupled means if I don't have any other database, like if I want to use any other database, let's suppose I want to implement MongoDB or Oracle DB or any other type of database, then I have to make changes in this user service class itself, right? So in here, if you see what this definition was saying, high level modules should not depend on low level modules. So what is this? This is my high level module. Sorry, this is my low level module, which is actually implementing the details of the operation. So MySQL database is implementing the method save, how it is going to save the particular information in the MySQL database. So this is low level module. And our user service, which is high level module. So what it is doing, it is implemented, it is using MySQL database, and this is highly dependent upon the low level module. And what this DIP says, high level module should not depend on low level module, right? Because if you see over here, it says that if I have to change this MySQL database somehow, then or if I have to use any other database somehow, then I have to make changes into this user service as well, right? So that's why it is tightly coupled to MySQL database itself. And this problem is going to be solved by DIP, which is dependency inversion principle. We'll see just after this. Okay, so how are we going to make sure that dependency inversion principle is adhered? So we are going to see this way. What its definition says? Its definition says high level modules should not depend on low level module. Then what should happen? Both should depend on the abstraction. So what is abstraction? Basically, abstraction is a middle ground between the high level module and low level module, which is going to separate out these two modules, and it will act as a middle layer between high level and low level modules. So that's what we are going to implement abstraction in here. So how are we going to implement this? We are going to create an interface database, right? And this database is going to have one method, which is save, correct? Now, this MySQL database is going to implement database. What is the benefit of this? In this way, whatever way this MySQL database is going to save the data into database can be implemented in its own way, right? So MySQL database may have certain different implementation. That's how it is going to save into the database, right? Into SQL database. Now, let's suppose here, if you see there is another DB, which is PostgreSQL database. So now this PostgreSQL database is going to implement the same save method into database in different format, right? So in this way, what we are doing, we are implementing the database method, database interface, and that's how each of the classes, which are different database types, they are implementing this save method in different ways. So that's what it is doing. It is basically cutting off the dependency from low level to high level. So basically it is cutting off the dependencies between high level and low level, and both of them are now relying on the middle ground, which is the abstraction. So now over here, if you see, user service is what? User service is going to instantiate its database instance, right? Which is a interface. Now dependency, through this dependency injection through construction, a constructor. So what is this dependency injection? Basically, through this, what we are doing, we are passing this interface instance into this constructor, and we are assigning whatever is the value of this instance into this database. And through this database, we are going to implement it into the user service class. So over here, if you see, this particular register user is not dependent upon anyhow on these classes like MySQL database, PostgreSQL database. It is now depending upon the interface, because if you see over here, we haven't talked about any particular database type, being it PostgreSQL or MySQL. We are not using anything over here. So if I have to tomorrow change something in this database type, I can definitely add some more databases, or I can make some changes, but it is not going to impact this user service at all. So that's how, using dependency inversion principle, we are making sure that our both high level and low level codes are separated out, and they are not dependent upon each other. So dependency inversion, so what it says, dependency of what? Over here, if you see, we have dependency of user service to the MySQL database, right? So high level module is dependent upon the low level design. So now over here, if you see, we have user service, which is dependent upon MySQL database, which dependency inversion says both of them should not depend on each other. Like high level should not depend on the low level code. Rather than, what is happening over here, we are inverting that dependency. Now user service at all is not dependent on low level code. So over here, if you see, user service at all is not dependent, right? It is not dependent on these classes, these low level implementations. That's what dependency inversion principle is doing. It is inverting the dependency. Now Postgre and MySQL databases, these methods, these implementations are dependent upon this, rather than user service is dependent upon this. Okay, so that's what is dependency inversion principle. So that was all in this particular video. If you found this video helpful and you got some insights of solid principles, please make sure to hit like button. That way it is going to reach to other persons as well like you. And if you have some doubts or some questions, you can ask in the comment box. I am going to happily respond to all of those comments related to doubts. And if you haven't subscribed my channel, please make sure to subscribe, because it is going to give me motivation to create more such insightful videos. And if you have any suggestions for me to create video on, please make sure to drop a comment. I am going to make video on that as well. With that, Amit Tripathi signing off.